Measuring potential difference and short time interval. By the end of this lesson, you should be able to measure potential difference using the CRO, measure short time interval using the CRO, solve problems based on the CRO display.
Okay.
What is the student measuring? What measuring instrument is he using? Can he use any other instrument to take the same readings? How would you determine the time between two heartbeats? The time between two heartbeats can be measured by measuring the time between several heartbeats, for instance, 21 heartbeats. Therefore, the time interval, or time between two heartbeats, can be calculated by dividing the time taken by 20. Is there any other way to measure the time between two heartbeats? A cathode ray oscilloscope, CRO, is used to display a graph of voltage against time. Voltage is plotted on the vertical or y-axis, and time is plotted on the horizontal or x-axis. The screen of the CRO normally has 8 divisions on the vertical axis and 10 to 12 divisions on the horizontal axis. Click on the switch to switch on the CRO. Notice that the time base is off. Adjust the X shift and Y shift knobs so that the green dot will be at the center of the screen or at the origin. Why do we need to have the green dot initially at the origin? We need to set the green dot to the origin so as to avoid zero error. Zero error is the error which is due to non-zero reading when the actual reading should be zero. Y gain is set to 1 volt per division, which means that on the y-axis, 1 division represents 1 volt. Time base is set to 0.1 second per division. This means that on the x-axis, 1 division represents 0.1 second. The Y gain and the time-based knobs of the CRO can be used to change the vertical or horizontal scales of the voltage against time graph. What does the voltmeter measure? The voltmeter measures the potential difference between points A and B. What is the potential difference between points A and B? The potential difference between points A and B is 3 volts. Switch on the CRO. Notice that the time base is off and the green dot is not at the origin. What is the appropriate step that should be taken next? The green dot has to be adjusted to the origin first. Click on the appropriate knobs to set the dot at the origin. What is the Y gain set at? What does the selected value mean? The Y gain is set at 1 volt per division. This means that each division on the vertical axis represents 1 volt. The CRO is connected across points A and B. What happens to the green dot? The green dot is shifted 3 divisions upwards from the origin. What does this indicate? The Y gain is set at 1 volt per division. The green dot is shifted 3 divisions upwards. The potential difference across points A and B is calculated by multiplying the selected value of Y gain to the number of vertical divisions from the horizontal axis. Thus, the potential difference across points A and B is 3 volts. Now turn the time base on. What can you say about the waveform seen on the screen? A green horizontal line is seen across the screen. What may happen to the horizontal line if the connection to points A and B is reversed? The horizontal line is shifted 3 divisions downwards from the origin. The DC power supply is now replaced by an AC power supply. The time base is set to on. What can you say about the waveform seen on the screen? a sinusoidal waveform is seen. What is the amplitude of the waveform displayed? The amplitude of the waveform is 3 divisions, which is equivalent to the selected value of Y gain multiplied with the number of vertical divisions from the horizontal axis. This amplitude is equal to the maximum voltage of the AC power supply. The maximum voltage is known as the peak voltage, Vp. What may happen to the waveform if the connection to points A and B is reversed? A sinusoidal waveform is still seen. Turn the time base off. What can you say about the waveform displayed on the screen? A vertical line is seen on the screen. What can you say about the length of the line? What does the length of the line indicate? The length of the line is 6 divisions. This is equivalent to twice the amplitude, or twice the peak voltage. Click on the switch to switch on the CRO. The pulses produced by the claps can be traced by the CRO. How much time does each horizontal division represent? The time base knob is set at 50 milliseconds per division. Thus, one division represents 0.05 seconds. How many divisions are there between 2 consecutive claps? The distance between 2 consecutive claps is 2 divisions. Determine the time interval between 2 consecutive claps. Since one division on the horizontal axis represents 0.05 seconds, thus the time interval between 2 claps can be calculated by multiplying the selected value of the time base to the number of horizontal divisions for one complete cycle. Thus, the time interval between 2 claps is 0.1 seconds. The waveform of the alternating power supply traced by the CRO is as shown. At what value is the Y gain of the CRO set? At what value is the time base of the CRO set? The Y gain of the CRO is set at 2 volts per division. The time base of the CRO is set at 5 milliseconds per division. What is the amplitude of the waveform traced? What is the potential difference of the AC power supply? The amplitude of the waveform is 4 divisions. The potential difference of the AC supply, V, can be calculated by multiplying the selected value of Y gain to the number of vertical divisions from the horizontal axis. Thus, the potential difference of the AC supply is 8 volts. What is the distance between two peaks? What does this distance indicate? What is the frequency of the power supply? The distance between two peaks is 5 divisions. The distance between two peaks represents the time interval between two pulses. This distance is equivalent to the period of the waveform. Thus, the period of the waveform can be calculated by multiplying the selected value of the time base to the number of horizontal divisions for one complete cycle. Thus, the period of the waveform is 0.025 seconds. Frequency is the reciprocal of period. Thus, the frequency of the waveform is 40 Hz. Click on the switch to switch on the CRO. Drag and drop the different power supply voltages. Click on the Y gain and the time base knob to vary the vertical and horizontal scales to get a good display of the waveform. What can you say about the graph produced?